Welcome my GCSE science students. In today's video, we're going to be looking at titration calculation. Now, this video is only for triple science students, okay? So if you're doing combined science, you do not need to watch this video. This is only for my triple science students. I've been getting lots of messages about doing titration calculation, okay? So just as a quick reminder, what is titration? Now you have a setup of all the apparatus here. Okay, and just a reminder, titration is a technique that is used to determine the concentration of an unknown substance. Okay, and you do that by adding a known substance. Okay, and then when they react, when they are neutralized, it comes to an endpoint which is indicated by an indicator. Okay, so it's using a known concentration of a substance to finding the concentration of an unknown substance by reacting them. Okay, please comment and let me know if you want me to go through this practical. Okay, but what we're focused on today is just about doing the calculations. All right, now the calculations is for all exam boards, AQA, OCR, EdExcel, and I'm almost 99.99% sure that these calculations always comes up on a paper 1. Okay, so you need to know the steps for doing this calculation. Now these steps, I can almost guarantee you that once you follow these steps, you will get full marks. Okay, all right, so you need to just set up your calculation card as shown here, your known, your unknown, because remember you have one that you're trying to find out, and you just do concentration, volume, moles, and ratio. And once you follow those steps, barring any mistakes with your calculation, you get full marks. Even if you do make mistakes, you can get the majority of the marks. Okay, all right, here goes. Let's see how we can get this done. All right, so here is a question. All right, so you have 25 cm cube of hydrochloric acid, and it is reacted with 23.50 cm cube of 0.100 moles per dm cube barium hydroxide solution. Now I know it sounds a lot, but let's dissect this. They've given you the equation for the reaction, and then they've now said to you, calculate the concentration of your hydrochloric acid. So straight away you know that that's your unknown. That's what you're trying to find, because they've asked you to calculate. It means that you don't know it. It's your unknown. They've given you the volume of your known. Okay. They've also given you the volume of your known. Okay. And they've given you the concentration of your known. All right. You also need to know this equation when you're going to do a titration calculation. And this is what I always say. If you're applying for a job, you always write a CV. Okay. Concentration and volume, they're beside each other. And at the top, you can have moles or you can have mass. Okay. So just remember concentration, volume. Okay. And concentration should always be in dm cube. All right, so here's my titration card setup. So what is it that we said that is our unknown? Our unknown is HCl. Our known is barium hydroxide. Okay, good. Now let's plug this in straight away. So what's the concentration of our known? That's given here. So that is 0.100 moles per dm cube. All right, what's the volume? That volume is given there, 23.50 cm cube. However, we need to convert that to dm cube, and we do that by dividing by 1,000. All right, so straight away when you divide that by 1,000, that's going to be 0.02350. Okay, and just remember that is dm cube. All right, now we need to work out moles. Now, how do we work out moles? Go to our triangle here. Moles is equal to concentration times volume. So it's going to be equal to concentration times volume. We have our concentration, which is 0.1, and we have our volume, which is 0.02350. Always remember to convert your volume into dm cube. All right, and if you've done your calculation correctly, you should end up with 0.00235. 0.015. Okay, and that's the mole. Now, next thing that we need to relate our known to our unknown based on the equation. That's where the ratio is coming from. So this is from the equation. Okay, from the balanced equation. All right, good. So the ratio is 1 to 2. So 1 mole of barium hydroxide, even though we're not seeing the 1, all right, from the balanced equation, it is a 1 to 2 ratio. So for every 1 mole of barium hydroxide, it is going to be 2 moles of hydrochloric acid that is required, which means that what I need to do with this is that I need to times that by 2, okay? Because this is the number of moles of barium hydroxide, and timesing that by 2, that ends up to be 0.00470 moles of hydrochloric acid. We've also been given the volume, which is 25.0 cm cube. Remember, we need to convert that to dm cube always. All right, and we do that by dividing by 1,000, and that's going to be equal to 0.025 dm cube. Okay, and then now we need to work out the concentration. And concentration is equal to, if you cover that, it's going to be equal to moles divided by volume. So I have my moles here, 0.00470. You divide that by the volume, 0.025, okay, and that's going to be equal to 0.188 moles per dm cube. All right, so the concentration, our answer, is equal to moles per dm cube. So technically what you're doing is you're working from your left going all the way around to the right side of your table. All right, 4 marks. Too easy. Too easy. This is 3 marks for you on your triple paper. All right, just remember, be confident, be positive, okay, like that proton. So have a look there. That's the mark scheme there. It's showing you every point where you're getting that mark from. All right. Okay, so here's another question. All right, let's have a look at this. Remember what we said that you need to be doing. You set up your calculation card, CVMR, concentration, volume, moles, and ratio. And that one equation that you need to know for this calculation is, if you're applying for a job, what do you write? You write a CV, and moles is at the top. Okay, so straight away, without even reading the question, we know what our unknown is. Our unknown is our sodium hydroxide. How do I know that? It's asked me to find it. You can only find something which is not known. Okay, so the student found that 25 cm cube of sodium hydroxide, okay, which is your unknown. So straight away you can put that in. All right, 25 cm cube. All right, so that is your volume, was neutralized by 15 cm cube, another volume of 0.0480 mole per dm cube, ethane dioic acid solution. Even if you've never heard of that acid before, it really doesn't matter. It doesn't change what we're doing. Oftentimes, those are just distractors, all right? So, what's the concentration of your known? Okay, let's put in that our unknown, sorry, our known is our ethane dioic acid. All right, so that is 0.0480 moles per dm cube. Our volume right here is 15, okay, cm cube. What should you do? Remember, you need to be converting that to dm cube, all right, by dividing by 1,000, which is going to be equal to, let me just make a note just in case you're watching and not sure what's happening there, and that's going to be equal to 0.015 dm cube. Okay, now how do we find moles? Moles is equal to concentration times volume. Okay, so it's going to be 0.0480. You're going to times that by 0.015. Okay, and that's going to give me an answer of 0.00 0.72 or 7.2 times 10 to the minus 1, 2, 3, 4, whichever, if you want to do it as standard form. I know you're triple science, you're watching this. I know you're also top set math, all right? So you know what's happening. Good. So straight away, we see that from the balanced equation, which is what we're going to get the ratio from, 1 mole of ethylene dioic acid reacts with 2 moles of sodium hydroxide. So it's going to be a 1 to 2 ratio, which means that what do we need to do here? We need to times that by 2. Okay, we're timesing that by 2 to now find the moles of sodium hydroxide, which therefore gives me an answer of 0.0144. Okay, good. All right, now this is our volume. What do we need to do with our volume? We need to divide by 1,000 because we're changing it to dm cubed, which means that that's going to give me 0.025 dm, dm cubed. All right, then we need to find concentration, which is moles divided by volume. So it's going to be 0.0144 divided by the volume, 0.025, which is going to give me an answer of 0.056 moles per dm cube. 0.056 moles per dm cube. Okay, good. All right, so that's your answer. Now, I know you might think this is a lot of calculations for 3 marks. I've just exaggerated the steps. Just follow the steps, all right? So you can have a look here. Okay, so that's the answer that we got, right? You can grab marks, okay? So even if you got something incorrect, they will use the incorrect answer for the calculation going forward. It's called error carry forward. You normally see that as ECF on some mark schemes, okay? Good. So just follow the steps. You don't want to lose these marks, all right? These are precious marks because you know you're aiming for that grade 8 or grade 9 or whatever your target grade is. Let's do one more question. I don't want to overwhelm you. You can pause the video, have a go at it, and then you can check our answers here. All right, let's go. So you're going to set up your calculation card. You're going to have your known, your unknown. All right, good. Let's read through. So you have 13.3 cm cube of 0.05 moles per dm cube citric acid solution was needed to neutralize 25 cm cube of sodium hydroxide. They've given you the reaction here. Back in my days, you would have to write that yourself and balance it, okay? But now you're given that equation, okay? Anyways, so it says calculate the concentration of sodium hydroxide. So straight away, that is your unknown. That's because that's what they're asking you to find, which means that your citric acid, your C6H8O7, that's your known. Okay, so what are we given? We're given the volume and concentration for citric acid. So we have 0.0500 moles per dm cube. Okay, good. Now you have your volume, which is 13.3 cm cube. Straight away, now I know that that needs to be changed to dm cube. All right, and changing that to dm cube, that's going to give you 0.013 dm cube. Okay, good. Then how do you work out moles? Just remember, if you're applying for a job, what do you write? You write a CV with moles at the top of that letter. Okay, doesn't make sense, but okay. So it's going to be C times V. Okay, so it's going to be concentration times volume. So it's going to be 0.05 times 0.013. Okay, and if you've done that correctly, that should give you an answer of 0.0000665 or 6.65 times 10 to the minus 4 rather. Good. Then let's look at the relationship, the ratio. It's a 1 to 3 ratio. So it's 1 to 3 ratio. So what do? We have to times your mole by 3, okay? And timesing that by 3 is going to give me an answer of 0.001 1995. That's now your moles of sodium hydroxide. They'll also give you that's 25 cm cube. We need to convert it to dm cube, as I've been saying to you. So that's going to be 0.025. And therefore, how do we work out concentration? It's going to be moles divided by volume. So it's going to be 0.001995. We're going to divide that by the volume, which is 0.025, which gives me an answer of 0.0798 moles per dm cube. Okay, good. Again, 3 marks. I think it could be worth 4 marks, to be honest, but they've said 3 marks, and you can have a look at the mark scheme there. Remember, just follow my steps. CVMR, concentration volume moles ratio. And remember, if you're applying for a job, you write a CV with moles at the top. Okay? All right. Please comment, please share the video. Let me know what other triple science topic you would like me to go through. All right. It's always good practice that when you get or you've gone through a topic, you need to do at least 3 of similar style questions, just like what I've done here. All right. All the best in your GCSE. Share with your friends. Remember, I'm out.